So by default, LLMs are non-deterministic, which means that if you change just one word in the prompt, there is a risk that the agent might hallucinate. So let's say you're implementing an LLM application. So here's your first iteration of the product. So this is the first iteration. This is the second iteration. The first iteration, you deploy it, and here there is a space of prompts and use cases of how your clients or users interact with the LLMs, right? Here are all the questions they asked, conversations they had with it. So now in your version 2, you have changed something. Now you have another set or another space of all the conversations, the interactions, the answers that the LLM is now giving in the version 2. So one user had one workflow in the first version of the LLM and it was working just fine. But you have changed something in the LLM. Let's say you have changed the prompt. Now that use case actually breaks. You might have fixed some other issues or things that the users were like reporting, but you have broken the previous use case that was working. And now you move to version 3, you try to fix this issue, but what happens is that you introduce more issues or you introduce other issues in different parts of this use case space. So the idea here is that when you move from one version to another, you do not test all the use cases and all the conversations that worked with the previous version. So how this is solved in traditional software engineering, in every version you have a set of tests and you do not deploy unless those set of tests have passed. And then you want to deploy the second version. So what you do is that you run the same tests, right? And you also run another set of tests called regression tests, testing the parts of code that you actually changed in order to see that your changes did not introduce any breaking changes, right? And then after those tests have passed, you then deploy. The same happens here. And if for some reason one of these tests break, like you introduce a breaking change, you do not deploy. You will like reiterate and you would basically try to solve this issue and then deploy the new version. By default, this is not done with agentic applications or with LLM applications. And this is actually a very common issue and very common problem. It's like a leaking bucket. So you fix one problem and you introduce a different problem. And because you do not track these problems, you do not track these issues and test cases, it becomes increasingly difficult to maintain the quality of your LLM, especially that your prompt is changing all the time. The models that you're using also changes all the time. The system overall, it becomes hard to maintain. So it's extremely important in use cases where the stakes are high, where the accuracy needs to be high and the error rate is not tolerable. So for example, let's say the extreme other case, like application like ChatGPT, the LLM hallucinations are tolerable because not all users actually need 100% accurate answer. They just want an answer to their question, and they're okay with some sort of inaccuracy because the return or the benefit from the system is higher than the loss from the inaccuracies that it introduces. And that's different from other applications like law or healthcare or financial applications, for example, where you need as accurate information as possible. Okay, now we identified the core problem, the core issue that we're trying to solve. Now, how do we solve it? So the solution to that is evaluation frameworks. Basically introducing a data set of tests that we can assess or evaluate our LLM before deploying it or before moving versions to keep track of the test cases that are failing and passing. Is just a way to structure the application to increase the quality overall of your application or of your LLM agent. And here there are two types of evaluations. There is single LLM interaction evaluation and multi-turn LLM interaction evaluation. So the single LLM interaction is when you try to assess or evaluate an answer just based on a single prompt. So you have one prompt, you have the input, and then you have some tool calls, some retrieval context if it's RAG, and then you have the output. So it's just a single interaction, and you want to basically assess or evaluate the LLM response based on the expected tools that should be used, the expected output, and also the context. On the other hand, multi-turn LLM interactions, that is when you have conversation that is going between the user and the agent, and then you want to evaluate the overall quality of the conversation. So for example, this conversation should have led to some outcome that you were expecting your agent to solve, for example, providing a refund or like booking a flight or doing something like that. There is a specific outcome that might be expected from this conversation, for example, that could be evaluated. So there is a scenario. So there is the scenario, there is the expected outcome, what should be the outcome of this conversation, and also the user description. These are the two types, single LLM interaction and multi-turn LLM interaction. So now what are the metrics? So we know, for example, for traditional software, the passing and failing criteria is fairly simple. There is defined input and the defined output. If the output doesn't match the expected output, then the result is failing. But for the LLM, there is not actually an exact set of words that define the final correct answer, right? And therefore it becomes a little bit more tricky. So what are the metrics that we can use to evaluate our LLM? I'll show you now the two most commonly used metrics for evaluating LLM responses. The first one is GEval or GPT eval. So for GEval, you have a task introduction. So you basically introduce the task that the agent needs to solve. Then you have the evaluation criteria. So what criteria we need to use in order to evaluate the final response of the agent. And then you have the evaluation steps. So what needs to be done in order to evaluate this response correctly. And here's the input context, like the data that has been given to the LLM and the system prompt. And here's the input target. In this case, is the summary that we want to evaluate. And the evaluation criteria here is coherence, as we can see here, coherence. Here, what we do is that we output a distribution, probability distribution that's coming out from the LLM based on all these criteria and data and the chain of thought. And then we take the weighted sum and we just report it. So let me show you another example really quickly. So another example could be correctness. So here, this example is from the DeepEval framework, which is an open source library, by the way. This is interesting and it's well maintained. So the metric here is correctness. And here's the criteria. Determine whether the actual output is factually correct based on the expected output. And here are the evaluation steps. So check whether the facts in actual output contradicts any facts in the expected output. You should also heavily personalize omission of detail. So this will depend on the use case that you're trying to evaluate. So the second most common evaluation metric is deep acyclic graph or DAG. So we use this when we want to break down the evaluation of the response. So let's say we have an article that we're generating with an LLM, and here first we extract the headings from the articles, and then we look for, does the summary heading contain all three: intro, body, and conclusion? So this is a must-have criteria that we want to have in the output, right? So if the answer is false, the accuracy is 0, or we report the quality score here is 0. If that's true, if the article contains intro, body, and conclusion, it passed the first step, then it goes to the second step. Are the summary headings in the correct order? Intro, body, conclusion. So they should be in the correct order. So if that is correct, just report that is 10 out of 10. So this is test case to assess whether the headings of the article are correctly formatted. So they exist and then they are in the correct order. If two of them are out of order, then report the score 4. If all of them are out of order, then the score is 2. So this is another way to have kind of granular assessment of the LLM output. These are the two main metrics. And I'm going to show you an example that I prepared with DeepEval. So for this example, I have a simple knowledge base, which is like some information about a SaaS product, like the pricing plans, the refund policy, and so on. And the agent here is a customer support agent that will answer the user queries regarding that service. Here I prepared two prompts. So there's the good prompt and the bad prompt. So the good prompt says you are a support agent for Cloud Sync Pro. Answer customer questions using only the provide documentation. If the answer is not in the documentation, say I do not have information. Do not make up information. Do not guess, be concise and helpful. So this is kind of a detailed prompt that's telling the agent to not come up with its own information. The bad prompt says you are a helpful support agent for Cloud Sync Pro. Answer customer questions to the best of your ability. Be friendly and thoughtful in your responses. So it doesn't mention any specifics about how it should answer. And here we want to evaluate or see the difference between how these two prompts perform, right? To do that, we have a set of test cases. So in this case, there are 5 questions, 5 test cases. So what is the refund policy for annual plans? How many team members can I have on the professional plan? And here there is the expected output. So the expected output for many metrics is not needed. For example, for the GEval is not needed because you define the success criteria yourself. And in this case, I'm using 2 metrics, the answer relevance accuracy and the faithfulness metric. So the answer relevance just tells how relevant the answer is to the question, because we want the answer to be as concise as possible. And also the faithfulness, which tells us how faithful are the information provided in the output. Is there something misleading in it, something incorrect? So these are the 2 metrics that I used for this use case. And I'm gonna run it against the first prompt and the second prompt, and I'm going to see the results. So here I have the results reported in the DeepEval dashboard. For the first test case, the question was, what is the refund policy for annual plans? Here was the output with the good prompt, with the first prompt. So for annual plans, the refund policy is full refund within 30 days, pro-rated refund available within the first 60 months, no refund after 6 months. So now the bad prompt, that we didn't give it enough details on how to answer, it said more or less the same thing. So full refund 30 days, no refund 6 months. To request a refund, you will need to email. Okay. Also worth noting, all plans come with a 14-day free trial, no credit card. So you can try it risk-free before committing to the annual plan. So this is actually might be useful in this case. But this is additional information that in some cases you might not prefer. You don't want the LLM to give extra information, you just want it to answer the question concisely. So that's why the score in this case was 1. So the score is 1 because the response fully addresses the refund policy for annual plans without any irrelevant information, making it clear and concise. So here the score was 67% because the response partially addresses the refund policy, but includes irrelevant information about the 14-day free trial, which do not directly answer the question. So this is a metric that you can define how directly relevant the answer to the question. The model here I'm using is GPT 4.1 mini. You might want to use a better model for your evaluations, and the same actually for other test cases. So for the good prompt, all the tests passed, 5 out of 5. For the second one, only 1 test passed and the other failed, mainly because they provided additional information or extra information or some irrelevant information to the question. So that is a way how you can systematically evaluate your LLMs. So now when you make a change, you can come here, you can run the same tests, the same experiment, and you can compare it with the previous one to see what test cases are failing now, and you can address it accordingly. So this is actually a very important thing to have, to be able to systematically assess or evaluate your LLM, because this will give you clarity, structure. You're not just moving randomly in the dark, but you have a clear goal, you have concise metrics that you are defining and tracking across your deployments. And here is a set of metrics: task completion, tool correctness, hallucination, summarization, bias, toxicity. There are a lot of metrics or a suite of metrics that you can evaluate against your LLM. So I hope you enjoyed this breakdown. Thank you so much for watching. Make sure to subscribe if you like this content. See you in the next one. Bye bye.